So a little bit more about exponents. I just want to show you a pattern. So 1 over 3 to the 4th could also be written as 3 to negative 4th. When you have a negative in an exponent, it simply means you take the base and put it in the, if it's in the numerator, you put it in the denominator and you take away the negative sign. You can work the other way as well. You can say that 1 over 3 to the negative 4th is the same as 3 to the 4th. Here we transferred the base, which was 3, from the denominator up into the numerator and took away the negative sign. I wanted to show you how those two are related. So a couple more examples. So 7 to the negative 2 would be the same as 1 over 7 squared. 1 over 5 to the negative 8 would be the same as 5 to the 8th. And 1 over 3 to the negative 3 would be the same as 3 cubed, which if you continue to multiply that out, 3 times 3 times 3 is 27. The last one I'm going to show you is negative 3 to the negative squared. We want to take this base, negative 3, and put it from the numerator into the denominator. We keep this negative sign right here, so it still remains a negative 3, but we remove this negative sign. We only remove the negative signs that are in the exponent. So this negative 2 becomes 2. Negative 3 squared is 9, so this would become 1/9. So negative 3 to the negative second power is 1/9. So I wanted to make sure you saw that the only negative signs that we take away are the ones in the exponent, not these. These remain. So the negative 3 still remains negative 3. The base remains the same. So if we take that one more example to make sure that you are following that, let's put it in the numerator, or let's put it in the denominator to start off with. Let's say 1 over negative 2 to the negative 3. We're going to take the base, which is negative 2, and transfer it from the denominator into the numerator, negative 2. And then in the exponent, we will remove this negative sign right there. We will move the 3 up on the top, keeping the negative signs for the bases, but removing the negative signs in the exponent. So 1 over negative 2 to the negative third becomes negative 2 cubed, which is negative 2 times negative 2 times negative 2, which is negative 8. So if you have a problem then working with exponents, we're going to work with exponents and variables. Variables, just the letters that are in algebraic expressions. So if we have x to the 4th times m squared times x to the negative 2 times m to the negative 5. And they ask you to simplify this expression, excuse me. So first we're going to take a look at the x. It's x to the 4th, and here's another x to the negative 2. So if you remember, when you multiply bases that have, or problems that have the same base, for example, x to the 4th times x squared, you simply, when you multiply these, you add the exponents. So this would be x to the 6th. The reason why that works is x to the 4th is x times x times x times x. We're multiplying that by x squared, which is x times x. So you can see there's 1, 2, 3, 4, 5, 6 x's. And that's how you get x to the 6th, and that's why you add these exponents. When you have negative exponents, you still add the exponents to get the answer. So let's start with the x's. X to the 4th times x to the negative 2nd. 4 plus a negative 2 is 2. So that would be x squared. Now we can do the same thing with these m's. As long as the bases are the same, that's this letter, this number, this variable. As long as the bases are the same, then we simply add the exponents if we are multiplying these bases. So 2 plus a negative 5 is a negative 3. So that becomes m to the negative third. So this is your answer. You can also write it as x squared over m cubed, because we can take this m, which is in the numerator, put it in the denominator, and take away the negative sign. So either of these answers are correct. If they ask you to simplify this, you could write x squared m to the negative third, or you could write x squared over m third. We're going to try one more that has, let's try one more simple one. Let's do x to the negative 2 times y to the negative 6 times y to the 5th times x to the 4th times z times x times z to the 5th. A lot of letters, but it's actually pretty simple. You just look for similar bases and then add their exponents. I see three x's actually. X to the negative 2, x to the 4th, and x by itself is the same thing as x to the 1st. So you would add negative 2 plus 4, which would be 2, plus 1, which would be 3. So this becomes x cubed. Now let's do the y's. The y's, there are two y's. X to the negative 6. Negative 6 plus 5 is negative 1. So it would be y to the negative 1. And now we have two z's. This z and z to the 5th. Z by itself is the same as z to the 1st. So you would add the 1 plus the 5 and get 6. So simplifying this gives you this. We're going to do one more that has the distributive property in it, because I want to make sure that you're watching the signs like we talked about in class. So we're going to take this and multiply it by p to the negative third, z to the 0, which if you remember, anything to the 0th power is just 1. Subtract it from 4 times x to the negative 5 and z to the negative 1. The distributive property tells us that we multiply this times this, and we watch this negative sign. Taking this part only, x to the 5th 0, y to the 0, 0 times p to the negative third times 0, z to the 0. We get x to the 5th, and there are no x's over here, so that remains the same. And then we have y to the 0, no other y's, and y to the 0 is just 1, so we don't have to worry about the 1, because when you multiply something by 1, you just get itself. So the y's are not, there are no more y's. Now we have z times z to the 2nd. Be very careful here. We have to see, sometimes when people multiply the bases with a 0, they think it becomes 0, but it doesn't, because z by itself is really z to 1. 1 plus 0 is 1. So this equals x to the 5th times z. You could put the 1 up there, but you don't need to. And now the only thing left to multiply is this p to the negative third. There are no p's right here, so it stays p to the negative third. So we just did this part. Now we need to do this part. Watching the sign, we put the negative sign down here. There's a 4. There are no numbers in front of this variable, so we're just going to put the 4 here. Now we have x to the 5th times x to the negative 5th. 5 plus a negative 5 equals 0. And if you remember, x to the 0 equals 1. 4 times 1 is just 4, so we're just going to leave the 4 here. We don't need to worry about that. They cancel each other out. Now we have a y to the 0, which is again just 1, so we don't need to put that down. Now we have z to the 1 times z to the negative 1. 1 plus negative 1 is 0. 0 to the, z to the 0th power is 1. And again, 4 times 1 is 4, so we're just going to leave that like that. And this is your answer. When you use the distributive property for this problem, you get this.